All right, so in the last video, we were talking about how to write linear equations given a graph. Now we're going to talk about writing linear equations when we're given situations and then how to use those linear equations. So here's the first one. The After School Activities Club charges $25 to join for the year, and it charges a materials fee of $5 for each activity you choose. So this is a one-time fee for the year, and then we have a materials fee, and this is our keyword for slope for each. So this is our slope keyword. And then when it comes to keywords when it comes to keywords for slope, we're looking for words like per, for each, or just each. Could be for every, but it's those where it's talking about something happening often, right? Now, for y-intercept, we're looking for one-time fees. We're looking for beginnings or starts. Those types of words indicate that we're working with a y-intercept. Depending on the money problem, if we're depositing stuff, our like initial deposit, that could be, and the keyword there is initial. Initial means to start. So initial is another word for start. Okay, so enough about keywords. Let's get moving here. We're going to write a linear function to the model, or to model the cost of joining the club and T activities. So T is like our X and C is like our Y. So we're going to have C equals something T plus something, right? So After School Activities Club charges $25 to join for the year. That's our y-intercept. Why? Because that's an initial fee, right? It's a one, in this case, we're working with that one-time fee, a $25 for the year. So we have plus 25, and then it charges a materials fee of $5 for each. So $5 is my slope. So I knew that M was 5 and B was 25. And so then this is what my equation becomes. Now it says find the value of the function for t equals -3. So here we have c equals 5 times -3 plus 25. And so c would equal -15 plus 25. So c equals 10. Now, so they're earning $10 for that. For what values will this function make sense? So let's think about this. T is number of activities you choose. Can we choose negative activities? And the answer is no. So it only makes sense for when T is greater than 0, which are positive whole numbers. Why whole numbers? Because you can't join half of an activity. You have to join the whole activity or none of them, right? So it doesn't make sense you can't join a negative number of activities. That doesn't make sense. And you can't join half an activity. So it makes sense for positive whole numbers. All right, next one. You go on a 5-day vacation and you bring $105 for spending money. You spend, so that normally means negative, right? $17 each of the first 4 days. Write a linear function that describes the amount of money, A, that you have after D days. So the spend each would be a -17 as my slope, because the each is my M. Now, we bring, so our initial value, that means this is my y-intercept. Now I'm going to write this one slightly different, but it means the same thing. So we want amount of money that you have after D days. So A will equal 105 minus 17D. Why did I flip it around? Because it makes sense to take our $105 and subtract the 17 we pay each day. All right, so that's the linear function. And now it says on the last day you want to buy a sweatshirt that costs $36. Do you have enough money to buy the sweatshirt? So we're on a 5-day vacation. The first 4 days we've spent $17 each of those days. So right now we have that A equals 105 minus 17 times 4. And so then I'm going to get my handy dandy calculator out and I'm going to take 17 times 4 after I clear what's in it. So 17 times 4 is 68. And 105 minus 68 is 37. And so 37 is greater than 36. So yes, we have enough. With $1 left over. All right. If we were less than 36, then we wouldn't have enough. And I believe that, yep, is the end of our lesson for 4.3. So until next time, 8th graders, be you.